So f inverse composed with f of x equals x for every x in the domain of your regular function f. And the composition of f and f inverse of x equals to x for every x in the domain of f inverse. So the important piece here is for the functions to be inverses of each other, there's the word and in the middle. What that means is when you compose the regular and its inverse and its regular, they both have to equal to what? X. Otherwise, if one of them is not equaling to x, meaning that they are not inverses of each other. They both have to equal to x. Okay? So the composition of the regular and its inverse must both equal to x for the two functions to be inverse of one another. And as you remember, the domain of your regular function is the range of the domain of your regular function is the range of the inverse, and vice versa. That's how remember how we always talk about, oh, let's switch the x and y's? That's what they mean, okay? So if you know the domain of the regular, then you should know the range of the inverse. If you know the range of the regular, then you should know the domain of the inverse. Now, this one says, the graph of your regular function, which is f, and the graph of your inverse are symmetric with respect to the line y equals x. Remember, we talked about symmetry with respect to y equals, right? Not y equals, the y-axis. And we talked about symmetry with respect to the origin. So now y equals x, what kind of line is that?
Diagonal?
Yeah, just like a simple straight diagonal line. So if I fold on that line and they line up perfectly, then those two functions are inverses of one another. That's why the composition equals to what? X. Okay, so they're all related. If a function, which is a regular function, y equals f of x, has an inverse function, the equation of the inverse functions is simply switching your x and your y. Okay? Not all functions will have an inverse function. Okay? All functions will have an inverse. Okay, so all functions will have an inverse. Whether the inverse is a function or not, we have to check it out. Okay? So normally, we don't write x equals, do we? So that's what we solve for y. So when we solve for y, we use this notation right here, f to the power of 1, and then composition of our input x. Okay. So let's try this one out. We have quite a few trig functions to graph. Why don't we graph this from negative 2 pi to positive 2 pi? And I'll give you guys a head start. See, I don't take out your line paper. Right. I'll give you guys a head start to graph that on your own. I'll catch up. Once you guys have your sine graph, when you compare it with your team, to make sure that we all have the same exact graph, make sure you guys have your tick mark on there. Label at least 1 or 2 tick marks so I know how much each tick mark is worth. Okay, Liam, sine of 0, Liam. What's sine of 0? Uh-huh. Do you guys agree?
Yeah.
Perfect. 0 is 0. Dot right there in the middle. Jason F., what's sine of pi over 2?
1.
Perfect. Sine of pi, please, Tani. Perfect. Sine of 3 pi over 2, Chris B.
-1.
And then back to 2 pi. Blake, back to 2 pi, sine 2 pi, hun?
0.
Perfect. So connect our dots. The other period, we are just going to follow our pattern. Okay, so there's our normal sine graph. Question is this a one-to-one? How do you know, by the way? What's a one-to-one function? It does not pass a horizontal line test, right? Meaning that if I were to draw a horizontal line anywhere, it intersects my horizontal multiple times. So this is definitely not a one-to-one. Is it a function?
Yes.
It's a function. It's not a one-to-one function. Okay. So because we said no, we have to restrict its domain. So it can be a
Function.
it's already a function. So it can be a one-to-one, okay? So it can be a one-to-one function. One-to-one function, y'all, it's even more narrow than a function itself. Okay, so in your teams, where would you cut off? So this can be a one-to-one function. Discuss it in your group. Where would you cut off?
Yeah, you basically
What's the largest restriction you can use?
no, because there's this one. So half of period, all of this is when you calculate sines or cosines.
That's true. In horizontal lines, you can't show
Horizontal, horizontal lines. So anywhere where you can't use
All right, raise your hand if you can give me a restriction. Sandra, what's up?
we would restrict it from the point at -1 to basically a half period. Like the point at -1 to the point at 1. No, wait, no, from 1 half. Okay, so it's a half, negative a half, and then positive a half.
Right here.
Yes.
The positive a half.
Yes.
Why not from 0 to here?
Because it would intersect twice in the horizontal line.
Okay. Why not here to here?
They could do that. Right?
Could I technically
Yeah.
go from here to here? You're right, right? Technically, you can take lots and lots of different intervals. But because universally, we just have to come together and agree on one set of domain, okay? So, as you already know, we are going to restrict it. Inclusive or non-inclusive?
non-inclusive.
Okay.
Inclusive. Non-inclusive.
So let's say that I'm going to go right here, because that's what I was told. Okay, now if I were to draw any horizontal, that's not what I want. I meant pi over 2. If I were to draw any horizontal line there, is it still going to give me a one-to-one?
Yes.
Yes, so inclusive or non-inclusive? Inclusive, right? Because it's not going to restrict me from being one-to-one. So negative pi over 2 all the way to pi over 2. So that's just what happens universally that we came up with. So definitions of your inverse of sine. So inverse of sine, it just simply, all we do is switch x and y. Okay, so we normally write y equals sine of x. Now we write x equals sine of y. We don't really typically use x equals. So how do we solve for y?
The inverse.
Yeah, we go in and we can compose. Remember this? We compose the sine inverse. So we go, okay, sine inverse of x equal to what? Y. Now, to give us a notation that we can all understand that it's an inverse of the original, we, instead of saying y equals, we go f to the -1 of x. Okay. This tells me that this is the inverse of my original function f, which is sine inverse of x. Now let's talk about the restriction of sine inverse. Remember, we limited the original. This was the original limitation of the domain. Would you guys agree? Because it was the original's domain, it turned to be the inverse what? Range. You're right. Okay. So we will write domain of the inverse, which is super important, and then the range of the inverse. The range of the inverse is from where to where? Negative pi over 2 to pi over 2. Now, more importantly, what is the domain of our inverse? Yes, inclusive or non-inclusive? Inclusive. Negative 1 to 1. Where did we get those values from? From the range of the regular. The range of the regular could only go from negative 1 to 1. Now, normally, I don't really say, oh, what's the range? I mean, sometimes I do. I normally kind of refer this back to the quadrants. What two quadrants is sine inverse restricted to? Quads, 4 and 1. Okay? Yeah.
Why wouldn't your negative 1 to 1 be your range?
It was my range in the regular, right? It was totally my range in the regular, isn't it? So here's f of x. The range was from negative 1 to 1. But in the inverse, guess what we do with the range and the domain? We swap them. Okay. So we talked, normally I'm going to refer, okay, well, what two quadrants is sine inverse restricted to? You would say that's going to be quad what? 1 and 4. Okay. So sine inverse is restricted to quad 1 and 4. Let's graph out our sine inverse function, see what it looks like. Okay, so here we go. We'll start with a negative pi over 2 here. We're going to do the regular first, and then we'll just reflect it. And then here's positive pi over 2 up here, negative pi over 2 down here. We'll do 1. 1 is about 2/3 of pi over 2, because pi, think about it, is about 3. Yes or no? Yeah, so 3 over 2 is about 1.5. So when you guys label 1, go about 2/3 of its way. I mean, approximately. Okay. We'll do the original first. Okay. The original, as you can see, I'm going to pinch it in really quickly. We had the original just from here at 0 is 0, pi over 2, we went to 1, and then negative pi over 2, we went to negative 1. So here's our original. Okay. As best as I can graph that. So this is f of x equals sine of x, original function. How do we graph its inverse? What do we switch? X and y. Would the 0, 0s be there? Yeah, the 0, 0 is still going to be there. Okay. How about this order pair over here? This order pair is pi over 2, comma 1. How would I switch that? 1 comma pi over 2, right? So 1 comma pi over 2. So 1's right here, pi over 2 is right there. So this is now 1 comma pi over 2. Then we have this order pair all the way down here, negative pi over 2 comma negative 1. How will we switch that piece? Negative 1 comma negative pi over 2. So there you go. That's my dot. Curvature is also important. Which way are they curving?
Down.
Upward. Would you agree that this curve right here, think about it, it's kind of hugging the x-axis, if you will? That means its inverse should be hugging the y-axis. It has to totally swap, okay? So curvature, this is going to be just like that. Okay. Now let's test it out. In the perfect world, this should be symmetrical about which line? Y equals x. So if I were to kind of sketch this out, this is the line y equals x. Is it about? Not perfect, obviously, because I'm human. I make human errors, but it should be symmetrical about that line. So whenever you're doing your homework or you're taking your test, kind of eyeball that line to see if it reflects, okay? All right, so that's your sine. Flip over to see what happens. If I'm going too fast, let me know. All right, go ahead and graph out that curve. What are we graphing next? Cosine. So similarly, just graph it out from negative 2 pi to positive 2 pi. Once you have a graph, can you compare that with your team? What's sine of 0? I mean, not sine, sorry. What's cosine of 0? 1. Good. Label your tick marks, huh? Oh, poor Bill. Will. He's still absent. He's so sick yesterday. Okay. Poor kid. He was like he came to the test all sick.
Did you say Bill or Will?
Will, I'm sorry, Will. Sorry.
No, call him Bill.
I was gonna call him Billy, you know?
Call him Billy. Call him Billy.
Nicole O, can you tell me cosine of 0 is? Perfect. Cosine of pi over 2 is, Ariane? 0. Cosine of pi, Angelina S. Negative 1. Cosine of 3 pi over 2, Tyson S. Cosine of 3 pi over 2, yep. Back to Sander, cosine 2 pi.
Cosine of 2 pi. You're asking me for the domain restrictions?
No, just what cosine 2 pi is.
Cosine of 2 pi. I don't know.
Consult your team.
Okay, so maybe 1. Yeah, it's 1.
It's 1, thank you. All right. Okay. I will repeat the dots on the negative period here. All right. Chi, not so chi, okay? Chi, is this a 1-to-1? No, you are correct, sir. Because we said no, we have to restrict its domain. So it can be a 1-to-1. All right, in your team, where should we restrict this? Discuss it. Where should we cut it off? Where should we restrict the domain so it can be a 1-to-1 function? All right, Hunter, what do you want to cut it off?
All right, we decided on, what was it?
It was, what's it? 0 to 5.
Yeah.
Inclusive?
Oh, yeah.
Yeah,
Yes.
okay. Here's 0 to pi. Looks good. Inclusive, 0 all the way to pi. Beautiful. Good job. So inverse of cosine, as you know, all we do is normally just switch y and x. Then we have to solve for our variable y. So we will go in and compose both sides with the inverse of cosine. So cosine inverse of x equals y which notation-wise we use f to the -1 of x. Okay. We will also state the domain and range of cosine inverse. Let me ask you guys, what is the domain of cosine inverse? -1 to 1. Where did we get those from? From the range of our regular. Okay. Now, what is the range of our cosine inverse? 0 to pi, inclusive, right? Okay. Now, I will also ask you the quadrants of cosine inverse. What two quadrants is cosine inverse bound to? 1 and 2, okay? Because it goes from 0 all the way to pi. So 1 and 2. Beautiful. Let's graph out regular first, and then we'll reflect it to get our, we're going to go from 0 to pi, 0 to pi, okay? Pi is about 3.14, so 1, it's a third of its way. So we're going to go 1 right here, 1 right here. We'll do the original function first. When cosine is at 0, we go to 1, okay? Cosine of pi over 2, we stay at 0. When cosine is at -1. When cosine is at pi, we go down and make a dot at -1. So this is a regular function. Restriction. F of x equals cosine of x. Now all we do is to reflect it, okay? Or switch x and y. So if this first point, y'all, it's 0 comma pi, this is 0 comma pi, 0 comma 1 I meant, sorry, 0 comma 1. How would I flip that so I can get an inverse point? 1 comma 0, so I'll get a different here. 1 comma 0, which is this dot. True or false?
Yes.
Okay. How about this point right here in the middle? This one used to be pi over 2 comma 0. How would we flip that? Pi over 2 comma 0. What would that be now? 0 comma pi over 2. So here's pi over 2, right smack center. So we would go with my red pen, go 0 comma pi over 2, red pen. Okay, so that is now 0 comma pi over 2. Now this third dot over here used to be pi comma -1. Okay, this third dot over here. Where would we flip that? -1 comma pi. All right, there's -1. We'll leave it with that -1. And here's pi. You got 3 dots. Should we make a straight line? No. How would we curve it? Okay, hug the y. It's perfect. Well said. We will be hugging the y going this way. Okay. And then I'm going to draw this line to see if it's somewhat near that. Does it look like it can be symmetry about y equals x? Yeah. Okay. Some of you are way better grapher than I am. Yes?
Would you draw arrows at the end of the, like...
These ones?
Yeah.
Oh, good question. Do not draw arrows on the end of these. Why? Because we chop them off, right? They don't go on forever. That's it. We cut them off right there. They don't go on. I'll leave it up. I'm going too fast. If you know how to graph tangent, go on. But I'm going to wait for a little bit. I talk really fast. I write really fast. So you need to let me know when I need to slow down. Go ahead and move on to tangent. Once you're done graphing tangent, please do consult with your team to make sure you guys have the same tangent graph. What's tangent of 0?
It's not. It doesn't
Undefined.
exist.
Well, tangent is y divided by x, right? AKA sine divided by cosine. At 0, what is cosine?
Cosine?
At 0, what's cosine? At 0, what is sine? So make sure we have the right value there. That's why we said consult with your team. Don't move on until you have confirmed with your team. I'm giving you guys a minute head start, so. Yeah, 1 is on the bottom. 0 is on the top. Can 0 divide by 1? If you know how to fill out the domain and range and all that good stuff for the inverse, go for it. Get a head start. So far, so good.
Because tangent is y over x.
Make sure you guys have asymptotes, guys. That means those dashed dotted lines. Make sure your asymptotes are on the graph of tangent. Label your tick marks, please. All right. Each tick mark on here is worth how much? A quarter, right? Pi over 4, right? Because what's the period for tangent and cotangent? Just pi. So if we go from negative 2 pi to 2 pi, it's going to be a lot, twice the amount of periods. So here we go. Tangent at 0. What is it? Is it 0 or undefined? I heard both.
0.
Is 0. Okay, so tangent at 0 is 0. What's tangent of pi over 4?
That's 1.
That's 1. What's tangent of pi over 2?
Undefined.
Undefined. We use asymptote. Okay. Then we're going to go to the negative pi over 4. What's tangent of negative pi over 4? Negative 1, because that's in quad 4 now. What's tangent of negative pi over 2? Undefined. So we have another asymptote. Once you have a few dots, because trig, it's repeating itself, so just repeat the decimals, the dots. And of course you can go beyond 2 pi, but I'm kind of running out of space, so let's stop there. How many periods do I currently have right there? Yeah, like this is one full period. Would you guys agree? This is another. This is another. This is like a little bit not a full one on that last piece. All right, is this 1-to-1? Not right now, right? Not right now. Okay. So because our answer is no, we need to restrict its domain. So our tangent can be 1-to-1. The regular has to be a 1-to-1 function for the inverse to be what? A regular function has to be a 1-to-1 function, so that way our inverse can also be a function. If it's not a 1-to-1, the inverse will not be a function, okay? So, what do you want to cut off?
Negative pi over 2 to pi over 2 not
Your
inclusive.
team answer for you. Okay. Would you agree that you could cut off from negative pi over 2 to inclusive or non-inclusive? Non, because those values don't exist anyway in tangent. So. Okay. So definition of inverse of our tangent. We switch x and y. So normally we go y equals tangent of x. Since we're switching x and y, we go x equals tangent of y. But there's nothing wrong with leaving x equals tangent of y. We are just normally see it in terms of y equals. So we go in and compose both sides by tangent inverse. Therefore, we have y equals tangent inverse of x. But just so we know that this is an inverse function, we use the symbol or the notation of y to the negative 1 of x. Okay? Domain and range. Let's work that out. What's the domain of inverse? Domain of tangent inverse is
Negative pi over 2, negative pi over 2. Well, positive pi over 2.
Are you sure?
No, it's all real numbers.
Isn't it all reals?
Yep.
Is it?
Because isn't the range of the regular all real?
Yep. Yeah, that one's all real. It goes up to infinity, right?
Yeah.
Oh, the range, yeah. The range.
All right.
So, yeah.
All right. It's all real. I will write all real, or if you feel like writing interval notation, you can also do that. I would take any notation that's right. Then what's the range of inverse?
Negative pi over 2 to positive pi over 2.
You're right. Okay. And again, I normally refer these as quadrants as well. What two quadrants do you think tangent inverse is bounded by? 1 and 4, right? Isn't negative pi over 2 is this way, y'all? What quadrant is that? 4. And then positive pi over 2 is that way. So that's going to be quad 1. Okay. So 1 and 4. That's similar to which inverse function? Sine. So sine and tangent are similar in terms of its quadrants. Okay, let's graph out our restricted f of x, and then we'll reflect it to get our inverse. Our restricted f of x was just from negative pi over 2 to negative pi over 2 to positive pi over 2. I mean 1 meaning that I'm going to have, so this is positive pi over 2, negative pi over 2. 1 is 2/3 of this distance, so that's negative 1. This is positive 1, negative 1. So asymptotes for our regular, we will start with negative pi over 2, one asymptote. The other one's at positive pi over 2. 0. Pi over 4 is smack center, so I'll make another mark right there. Okay. At pi over 4, go up 1. At negative pi over 4, go down negative 1. And here is the inverse. I'm sorry, here's the regular. I lie. This is y equals tangent of x. Okay, restricted. So now we are going to try to graph its inverse. All right. How do you want to graph your inverse? What do you want to start? What's the easiest way for us to start? Switch to x and y. Should we graph the asymptotes first? Yeah, let's do that. Where should we put the asymptotes on the inverse? Pi over 2. Good. One of them. What else? Negative pi over 2. Beautiful. Okay. Then the dot at 0, 0 is still going to be there. Okay. This dot over here, this dot is called pi over 4, comma 1. How do we switch that? 1, comma pi over 4. And again, pi over 4 just smack center there. So I'm going to make a dot at 1, comma pi over 4. There's my 1, comma pi over 4 dot. This dot over here is negative pi over 4, comma negative 1. And we will switch that to what? -1 comma -pi/4. And again, pi/4 is right smack center in between that. So -1, whew, there you go. Curvature, which way are we going? Can you turn your paper? I mean, I can't turn my computer because if I turn my computer, honestly, it's going to flip the screen on there. So if you turn your paper, you can also graph that way, right? So in the perfect world, these two should be reflection about which line? Yeah, okay. Which, if I'm like a really good grapher, they should look pretty. So asymptotes are there for a reason, guys. Asymptotes meaning that the curve will get really, really, really close to it, okay? All asymptotes behave the same way. Asymptotes is there so that way the curve gets super close to it. Some asymptote you can cross over, some asymptotes you can't. Okay. How good are you guys at calculator skill? Good? Questionable? All right. Bust out your calculator. Let's see if you can get the answer to 1A, B, and C only, okay? If you need to borrow a calculator, come on down. Stretch your legs. If you don't know how to use a calculator, that's okay. I'll teach you. So, try it out. What's in your calculator? Now, before you write in your notes as a permanent answer, can you please share your answers with your team? Okay?
Yeah, -7.46.
Okay, so just try out 1A, B, and C. I'm not really looking for a perfect answer. I'm just looking to see where we're at on calculator ability. So you need.
I think you just need to go to regular calculator.
As you know, of Unit 1 test yesterday, I cannot help you on the day of the test. So when we're practicing calculator, you gotta work, you know, you don't know.
Wait, so for A it's -0.13.
For A, it's
Just do A, and then talk it out in your team to see if you guys all get the same answer. If you don't have the same answer in your team, figure it out. Like, hey, how come my answer is different from yours? When you get a question, I got mine.
I don't know.
Oh yeah.
Okay.
You're describing something in.
Question was, should we be in radians or should we be in degrees? No, we should always be in radians unless it's stated otherwise. So everyone hit mode. Hit mode, go to radians if it's not already there.
Always we're supposed to be.
Yes. Remember, class, all the restriction we have done so far, isn't it from -pi/2 to +pi/2? Or from 0 to pi? Those are all what? Radians. Okay. So your calculator's got to be all in radians unless it's stated differently. So hit mode, go to radians.
So wait, this is how many radians?
No, that is radius. That's definitely radius.
Okay, but like.
Just try to break that down.
Okay, that's how many pi radians.
Okay. How do we enter example 1A in the calculator? What do we press?
Second sign.
Second sign. Okay, so we sign inverse. And then we put in a -0.13, round to decimal places. What is the answer for 1A? -1.13 happens to be not the same. Is it always going to be exactly the same as that value in there? No, just for that case. Okay, so that's going to be. So this one happens to be -0.13 back. How about B? What button do we press on B? Second cosine, and then 1 divided by 8. Okay. What's the answer there?
1.45.
1.45, someone confirm, deny?
Yes.
Okay, so 1.45. Okay. Tangent inverse. What would that be?
0.33.
Ooh, 0.67, 0.33, got you many answers.
I got 0.33 as well.
What do we press?
Probably just did the wrong.
Second, tangent, and then quantity, right, y'all?
Oh, yeah.
Quantity, graph 3 divided by 5. So, that gives, one more time, what was that decimal? 0.33. Okay. Make sure we are in what mode? Radians. Now, example 2. For your homework, okay, from here on out, unless it says round, then that's when you can use a calculator. If it doesn't ever ask you to round, that means everything must be done without a calculator. So example 2, find the exact value, calc or non-calc? Non-calc. Okay, so we tested our calculator skill. We are great. We know to put it in radiant mode. Exact value. Sine inverse of 1. What do you think the answer is?
Pi over 2.
How do you know?
Because sine pi.
Right. So we go backwards, right? We're going to say, hey, sine of what equals 1? Okay. Remember, inverse is switching x and y for x, switching domain and range. So this should be pi over 2. Okay. Now, if you're kind of puzzled with this, what you want to ask yourself is sine of what equals 1? Okay, so that's the reverse thinking of that. So final answer is pi over 2. 2b. Sine inverse of a half is what?
Pi over 6. Something like that.
Sine inverse of 1/2. So now we're going to ask ourselves, right? Sine of what is 1 over 2? So some of you, that's why you have to know the unit circle really, really well. You got to be able to spit it out just like that at this level. Okay. So I'll write this question. If you don't know it or you don't see it, I'm going to make a box for our answer. Then the reverse order of that is 1/2 equals sine of what? And the radiance answer is pi over 6, which is equivalent to 30 degrees. Okay? So this answer is pi over 6. That means our final answer is pi over 6. I'm going to hold on tight so you can ask questions before I go further. Any question of how we get the answer, the reverse thinking of what we're used to? I know you did this in algebra trick already. Am I right?
Yeah.
Okay, perfect. Then spit out the answer to number C, or letter C.
3 pi over 4.
Oh.
No, it's not. It's negative, yeah. So.
My fault. Cosine inverse restricted in what two quadrants?
1, 2.
1 and 2. It's a negative at 2 over 2. So the answer has to come from what quad?
2.
2. So let me write that down for us. Cosine inverse restricted in 1 and 2.
Oh, no, yeah.
Okay.
Yeah.
3 pi over 4 will give me a negative at 2 over 2. So final answer is 3 pi, not 3 over 2, 3 pi over 4. Sorry about that. Okay. Always go back to our restrictions. You may not have outside restriction for inverse functions. Last few, and then cosine inverse again, restricted in between what quads? 1 and 2. All right, perfect. What's the answer?
1. Oh, wait, yeah. Okay.
Pi over 2, right, y'all? Okay. Tangent inverse restricted where? What quads? 1 and 4. It's a positive rad 3 over 3. So what quadrant is the answer going to come from? 1. What radiant in quad 1 will give me a rad 3 over 3? Probably pi over 6. You guys agree? Okay. How come I can't have an answer in quad 4? That would be a negative. You are correct. Okay. Last one, and then we'll call it a day.
4. Pi over 4.
Pi over
4.
4. Because it's a positive 1. Tangent of pi over 4, it's positive 1. Because tangent inverse, again, is restricted in 1 and 4. All answers in quad 1 will result in a positive answer. That's an egg roll.